All right, so here we go. So we just did addition and subtraction of radical expressions. So what's next? I want to do multiplication. So multiplying radical expressions. And we'll just start with multiplying them in radical form. So if you're multiplying radical expressions, you must have, if we're doing them in radical form, we want the same index. That's really all that we want. We don't need the same expression underneath the radical sign, but we want the same index, okay? When we get into other indexes or indices or whatever plural version of that is, then we can look at the rational exponent version of radical expression. So anyway, let me just show you some basic stuff before we go into, in my next video, I'll do that. So 2 minus the square root of 5 times 3 minus the square root of 5. So these are radical expressions. They actually are, this is a binomial times a binomial. And actually, if you remember, back in when you dealt with polynomials, I don't know why that. When you dealt with polynomials, you multiplied binomials. If you're multiplying a binomial times a binomial, it doesn't matter what the binomial is. In this case, they're radical expressions. We're still going to FOIL. Multiply the first two terms. Outer, 2 times the square root, or the opposite, 2 times negative square root of 5 is a minus 2 times the square root of 5. Inner, negative square root of 5 times 3 is a negative 3 times the square root of 5. And last, now you see how when I multiplied this number 2 times the square root of 5, I didn't multiply the 2 and the 5. I didn't get 10 because 2 is outside the radical and 5 was inside. So I cannot multiply those two numbers. Keep the 2 outside and the square root of 5, or the 5 inside. But if they're both under the same radical with the same index, then I can multiply the two numbers. So a minus times a minus is a plus. It's a square root and a square root, so square root. And then I can do the 5 times 5, 25. So I can only multiply two numbers if they're both outside of the radical or both inside the radical or underneath the radical with the same index. And then we simplify. So this is 6. These are like radicals. Minus 2 of these square root of 5s, minus 3 of them. So keep the square root of 5, work the coefficients. Negative 2 minus 3 is negative 5 times the square root of 5. I'm running out of space. Put that too close. Okay. And then actually the square root of 25 can be simplified. Anything that can be simplified, you have to. You have to go all the way. Square root of 25 is 5. So actually now I have two like terms, 5 and 6. So now I have 11 minus 5 times the square root of 5, which is my final answer. Okay. Now, they don't all have to be FOIL situations. They could technically be, a single term times a double term or whatever. I'll show you what I mean. Here's example 2. Actually, it's going to get even easier if I do it that way. But let's do 2 times the square root of 3 times the quantity 2 times the square root of 5 minus 4 times the square root of 3. Let's do that. So I'm multiplying radical expressions, but this is a single term times a double term. You see, these two are subtracted, but I can't combine them because they're not like radicals. So this would be the simplified version of this expression. I can't bring the 2 and the 4 together. They have to be like radicals to bring them together. So this is a binomial. I can't simplify this anymore. But if I want to multiply this binomial by this monomial, this single term, and distribute. I'm using terms from polynomials just to kind of like refer back to that a little bit. But anyway, so if I want to multiply the 2 times the square root of 3 times the 2 times the square root of 5, the 2's can be multiplied because they're both outside of the radical. So 2 times 2 is 4. Let's multiply now underneath. Now they're both square roots, so I keep my square root. 3 times 5 can be multiplied because they're both underneath a radical, square root of 15. Let's do this minus. So 2 times -4 is -8. They both stay outside. And then this 3 and this 3 can get multiplied because they're both inside. Simplify if I can. The square root of 15, first of all, 15 is not a perfect square, so that's not going to work. And there is no factor of 15 that is a perfect square. So this is going to stay as is. Square root of 9, however, can be simplified into a 3. So I'm going to rewrite this. I have 4 times the square root of 15 minus, this is 8 times 3, which is 24. So 4 times the square root of 15 minus 24 is my final answer. And sometimes you'll see it written as, you know, the non-radical sign or non-radical term first, and then following with the radical term. They're both the same thing. So this is multiplication of radical expressions in radical form.